So this video's aim is to help you with solving trig functions. There's no differentiation in this one. This is just about solving for trig. So let's start with some basic good old sine ones. The first thing that we need to do is make sure that we get sine by itself. So we can get rid of this times 2 and the plus root 3 goes on the other side. So simple algebra that everyone is comfortable with. So we end up with that's minus root 3 on 2. Now, as soon as we see that, that is one of the exact solutions that we know. If you don't remember what it is, then please go back and look at your table where it has all of the options. So either your sine diagram or your table here. So we're looking at when is sine root 3 on 2. Now, I know our answer had minus root 3 on 2. You'll see at the moment, I don't care if it's negative or positive because, well, it just tells us our working angle, which is pi on 3. So I now write over here, that means I'm working angle is pi on 3. It is now that I take notice of the signage. So I draw my rude diagram or crude diagram for the unit circle. And remember, sine is your y-axis. So where is the y-axis, sine, going to be negative? And that means we're in these two quadrants, 3 and 4 downstairs. That's 0, that's pi. And we always go from the horizontal. So we're going to go down there. So we're going to add on. We're going around the circle like so. We're going to add on 1/3. And then from here, we're going to take off 1/3 pi. So go back to your good old fraction days. What is a whole pi plus 1/3 of a pi? And I'm hoping everyone is calling out to me there. 1 plus 1/3 is 4/3. So we just pop the pi in there, 4 pi on 3. Now this one, remember if we're going around the circle, 0, pi on 2, pi, 3 pi on 2, we come back here to 2 pi. So it's 2 pi minus 1/3 of a pi. I like to tell my students, think of, you've got 2 pies cut into thirds, so how many slices? That's 6. 6 take 1/3 will be 5. So it's now 5 pi on 3. If I didn't have this domain here, I would be saying plus k lots of 2 pi because 2 pi is the period of our sine function. In this case, it's just between 0 and 2 pi. We've got all of our solutions. Graphically, what this question is asking you for is here is minus root 3 on 2. So minus root 3 is around minus 0.86. You can check that on your calculator if you so desire. So that's that. What the question is asking you for is, can you please solve for when this cuts your axes? And so what we're saying is it's this solution here, which is the first one, which is 4 pi on 3, and then this is giving you our second answer, which is 5 pi on 3. A second option that you have is at this point here, when you've got sine x is minus root 3 on 2, some students like to just look at their unit circle. So if we go back to our diagram here, remember sine is your y-axis, and so you're looking for when have we got sine being negative root 3 on 2. This means you have to remember that, well, because we just said sine is the y-axis, this is your y value here. So I shouldn't be looking upstairs. If I'm wanting a negative value for the y, I should be going down here, and you can see it corresponds, negative root 3 on 2, that's 4 pi on 3, and over here 5 pi on 3. You might think that's easier because you can just go here, but trust me, for questions later on, you're better off sticking with trying to find the working angle and then the quadrants. Right, let's move on to now a slightly different one. It's still sine, but this time we've got the 2x. With your knowledge of sine graphs and what things affect the amplitude, the period, your vertical translation, all that sort of stuff, we should realize that this 2 in front of the x, that makes our original sine graph here, the green one. What happens now is when we have a 2 in front, it means we have 2 graphs within that same period. So the period of this graph has now changed it is now just pi. You'll see how that affects my solutions in a moment. So same thing now, we're going, okay, well, sine of 2x equals equals 1. When does sine equal 1? You can look at that from your unit circle, your graph. I like to look at it from my graph here. So when is it 1? Right there for pi on 2. So we can say that x, or in this case, 2x equals pi on 2. You might be wondering, why haven't I done the working angle and looked at the quadrants? Well, this is because 1 and 0, they're special cases. That's when it's right on a maximum or a minimum, and so we're not worried about which quadrant it's going to be in because it's not on a quadrant, it's on an actual edge there. However, we do have to consider the period. So we could say this is plus pi on 2 plus k lots of 2 pi, because as you can see, when we're looking at the purple graph, I don't have just one solution when it's 1, I have a second one here. So how do we solve this? Easy. We say, right, how do I get rid of that times 2? I'm going to divide through by 2. And the bit to remember here is you must divide everything through by 2. So it's this bit here as well. So now you can see what happens, and the period, the plus k pi, that's what my period was over here. One cycle of the graph for sine 2x. And now we go, right, well, how many times do we have to keep adding on pi before we get to the end of our domain? So we can go, right, we've got that original one. Now when I'm doing this, I've got pi, a whole pi, because I'm doing in quarters, then a whole pi is 4 pi on 4. So add on 4 to that, so 4 plus 1, we get 5 pi on 4. I could keep going, so add on another 4 to that. This is 9 pi on 4. Is 9 divided by 4 less than 3? Yes, it is. So remember, this is now going onward down here, so this graph would keep on going. That's why I have a third solution. Can I add on another pi? So plus 4 again, so that's now 13 pi on 4, but you can see at this point 13 divided by 4 is more than 3, so I've reached my limit. That's it. These are the 3 now solutions that I have for that graph. Right, moving on to, we'll now look at some cos functions. And you notice now I haven't got the graphs anymore. We don't want to have to draw those every time. We want to just do the algebra process. So remember, the first thing we want to do is to get the cos of whatever it's cosing by itself. So we're going to go cos the minus root 2 on the other side, and the 2 we divide by. So we're left with x minus pi on 3 equals minus root 2 on 2. We have to find our working angle. So our working angle for this one is pi on 4. If you don't remember that, then you need to go back to the circle. So we're looking here. When have I got cos of root 2 on 2? That's pi on 4. So try and remember these essential things that makes life easier for you. So back we go. I take a look. I want to know, when is cos negative? So we're back to using our beautiful sketch of the unit circle where no circle exists. When is cos negative? Remember, cos is your x-axis. So we know that that is negative in this quadrant and this quadrant. Remember, that's pi. I'm going to subtract 1/4 pi from there, and I'm going to add on 1/4 pi to there. So therefore, I've now got x minus pi on 3, because that's what I'm cosing in effect. That's going to now equal, so pi, take 1/4 pi. So whole pi is 4 on 4. So 4 take 1 becomes 3 pi on 4. And a pi plus 1/4 pi becomes 5 pi on 4. And remember, we're going to go plus k lots of 2 pi. In this case, this period is not going to change. It's only if there's a number in front of x. So 3, a 4, a half, that changes the period. This does not. This take pi on 3, that actually moves the graph to the right by pi on 3, so it doesn't affect its period. And now it's a simple matter. How do I get rid of a take pi on 3? You simply plus pi on 3. So it's going to be x equals 3/4 on 4 plus pi on 3. I don't normally write this. I leave out this line. I'm just writing it so you can see what's going on there. I do not take it or add it onto this because its period is unchanged. It's just moved. The graph is just moved from one section to the other. At this point, I can get my calculator out and just go, what's 3/4 plus 1/3? Gives me 13/12, and we just stick the pi in. What's 5/4 plus 1/3? 19/12, and stick the pi in. We now have to go back and look at our domain. Can I add on another 2 pi, another lap, and get 2 more solutions? And because we know that it goes, the basic cos graph takes 2 pi to complete one cycle, we would expect that we could get 2 more solutions within 0 to 4 pi. We might not get the fourth, it might be 3 because this has moved the graph over. Anyway, we must check it out. So the way I do it when I'm dealing with 12ths here, 2 pi, would you agree, is 24/12. So what I'm going to do is add 24 to each one of these, and I keep doing that until I'm beyond 4 lots of that, which would be 48. So I keep the original 2 solutions that are valid. 19 pi on 12. All right, and now we go, what is 13 plus 24? And we end up with 37/12. That is less than 4. 37 divided by 12 is less than 4. Now we take the 19 plus 24 and we get 43. That is also within our limit because remember, 4 12s, 4 times 12 is 48. As soon as I get to 48 pi, that's too much. So I've added this one plus the 24, aka the plus 2 pi. I got this answer, and then I added another 2 pi to get this one. So the next solution, if there is to be one, I take this answer and I add 2 pi to that. However, when I do add 2 pi, 2 lots of that to 37, so 37 plus 24, that gives me 61/12, and that is well beyond our 4 pi because 61 divided by 12 is 5. So that's not a solution. So these are my 4 solutions that I stick with. All right, so that's basically how it's done. I think we'll leave that one for another day. I'll just show you one of these that we have prepared earlier. So a question like this has basically most things in it. It has a slightly different domain. So step 1, what we've been talking about is you need to get the sign of whatever it is by itself. So you can see that we've done that. Step 2, we establish the working angle. We then identify the quadrants that it's in. Why is it down here? Because we had sign of a negative, and we know sine is our y, so we go downstairs. Then we want to state the solutions for one revolution. We've got the plus k2 pi here. And just like we did with the last question, to get rid of the plus 5 pi on 6, we subtract. We keep going for our domain. So you could have a read of this or cover it up, try it yourself, and hopefully that helps with solving trig graphs, trig solutions. Thank you.